calculus is basically the subject to do with finding the gradients on a curve. So if we look at something like this, we'd find out that this gradient's about 1, here the gradient's about 0, and here the gradient's about -1, and this is what calculus is here to find, gradients. So calculus is a bit like a gradient calculator. So you put in x values and you get out gradient. So if we look at it here we've got some random curve, and if we put in, say we want to find out the gradient at x equals -1, well, here's the point, and we put in -1 into our gradient calculator and it gives us 2. And we look at that, yep, that's about a gradient of 2. Perfect. We want to know the gradient at 1. Well, we chuck 1 into our gradient calculator. It gives us 0. Yep, that makes sense, the gradient's about 0 there. And we want to find out what the gradient is at 3, so we put in 3 into our gradient calculator, and it gives us -1.2. And yeah, that makes sense. Okay, cool, that's about -1.2 there. This thing here, which is called a derivative, is actually a gradient calculator. It calculates what the gradient is. So here's an example. So we've got f of x equals this junk over here, and f dash of x is the gradient calculator. Now, I'm not going to show you how I figured this out right away, but it does actually equal this. So if we want to find out gradients of f of x, we actually use this thing here. And so if we want to find the gradient of f of x at x equals 1, well, we just sub in 1 into f dash of x, and so that's 6 times 1 minus 5. 6 minus 5 equals 1. So the gradient at x equals 1 would actually be 1. So the gradient is going to be something like that. And if we want the gradient of f of x at x equals -2, well, we do the same thing. We sub in -2, and it's 6x minus 5, so 6, -2 minus 5, which gives us -12 minus 5, which gives us -17. So the gradient would be -17, which would be quite, that's a horrible line. Something like that, you know, very steep but negative.